Hello, this is Math 2231 coming to you from the College of DuPage during the summer of 2020, and this lecture is entitled A Gentle Enrichment Introduction. Let's remind ourselves of some integrals that we know how to do. The indefinite integral of e to the x dx is known to be e to the x plus c. And similarly, if we had the indefinite integral of x, e to the x squared dx, we would know we could do a u substitution. You let u equal x squared, du would be 2x dx. X dx is going to be 1/2 du, and magic will happen. Your x will cancel out, and you will have that this integral is equal to this once you substitute the u. The indefinite integral of e to the u is e to the u plus c, and then I'll substitute back what u was, and it is 1/2 e to the x squared plus c. But this integral you don't know how to do, because when you try to find the indefinite integral of x e to the 6x dx, you can't let u equal 6x because magic will not happen. You'll be stuck with a u and an x inside the integrand. So we're going to develop an integration by parts formula, and I'm going to start and finish with this. But this is the thing that you need to remember, and it's really a double substitution. We're going to figure out what is u and what is dv. And then the formula is going to be the integral of u dv is equal to uv minus the integral of v du. Now this comes directly from the product rule. The product rule for f and g is this. So if I integrate both sides, I will have this. But the integral of the derivative of fg prime is fg, and I'll integrate term by term and get this, and I will call f of x being u, and I will call v being g of x, and when I substitute things in, I get this formula. Notice that what I'm doing is I'm solving for this part right here, and that is going to be u dv. So again, the formula to remember is the integral of u dv is equal to uv minus the integral of v du. This is committed to memory, and it is a double substitution. You pick u and everything else is dv. You pick dv and everything else is u. Okay, so to use this formula you have to identify u and dv and use the formula. And it's sometimes complicated because you say, well, which do we let be which? Well, some of it will come with experience, but you know you've made the correct choice if at the end of the integration by parts formula, the new integral, the one on the right of the formula, is one you can evaluate effectively. So let's look at the example. This is the problem that we started with. We're going to do a double substitution. So we're going to let u equal x, and then everything else has to be dv. So dv is e to the x dx. Now that's the substitution. Now we're going to do the calculation. So du is dx, and v, we have to integrate going from here to here, is going to be 1/6 e to the 6x. We can let the constant be 0 here, and the final constant will absorb any of the additional constants along the way. So the integral of u dv is uv minus the integral of v du. This is one we can compute, and we compute it in this step, adding our constant of integration. This is a very neat technique. We can also use it with definite integrals. So if the definite integral from a to b of u dv is what we encountered, that's the same thing as uv evaluated at b minus a, minus the integral from a to b of v du. Let's apply that to the problem that we just did. So here we found out that this antiderivative was this one, and we plug the numbers in, and either way we're going to get 11/36 e to the 12 plus 7/36 e to the minus 6. I note that although this doesn't look like a number, it is a number because e is a number. Okay, let's do this example. And so we have, we're finding the indefinite integral of 3t plus 5 times cosine of t over 4 dt. Now, what we have to do is, in this case, we will let u equal 3t plus 5. And everything else has to be dv. So this is going to be cosine t over 4 dt. Now we do some computation. So here we're going to integrate dv, we're going to get v. Here we're going to take the differential or the derivative of u times dt, and that is du. So the integral of u dv is equal to uv minus the integral of v du. Now notice that we get the 3 times the 4, that's where the 12 comes from. We calculate this integral and we get, this is going to be minus cosine, and we get another factor of 4 when we change that variable, and this is the final answer you should get. Let's look at this one. Now this one we're going to end up integrating by parts twice, but we have w squared sine of 10w dw. So we notice that if we start taking the derivative of this, it will get simpler, and we know how to integrate the sines and cosines, so this will be okay. Let's start this way though. We let u equal w squared, and everything else has to be dv. So that is sine 10w dw. I integrate this one, getting this. I take the derivative of this, getting this. So the integral of w squared sine 10w dw, that's the integral of u dv. It's going to be uv minus the integral of v du. And again, what happens here now is we have integration by parts again. So the 1/5 is going to sit there, and it will be this 1/5 down here. But now we have to integrate by parts again, so we're looking at just this part. So we're going to let u be w, then du is calculated to be dw. Everything else except for the w is dv, so we integrate this and we get 1 over 10 sine 10w. So you see we have this integral is going to be what we had before, and then we integrate it by parts again, we distribute and we simplify, and this is what we get for our final answer. Another example here, we have this one. This could be done by Calc 1. We're just going to do it using integration by parts. So we're going to let u equal x, and everything else, that is dv, is equal to, and this could be thought of as parentheses x plus 1 whole to the 1/2 dx. So this is going to add 1 to the exponent, divide by the new exponent, and over here I calculate this and I get dx. So the integral of uv is integral of u dv is equal to uv minus the integral of v du. I do this calculation with the u substitution. U again, over here it's a different u, I suppose, is x plus 1, and I get this as my answer. One more example. We're trying to integrate the natural logarithm of x dx. Now I show here a mistake because this didn't work, because we got the same thing back again. So we'll try something else, and this time we're going to try something that will work. We're going to let u is equal to ln x. That means we're going to let dv be dx. Some of my students say, can I do that? Of course you can. So if dv equals dx, that means v is equal to x. We just integrate both sides. And here we compute, so this is going to be 1 over x dx. So the integral is the integral of u dv is equal to uv minus the integral of v du. And notice when I multiply those together, I'm just going to get 1. So that's the integral of dx, which is x. And so the final answer to this is x ln x minus x plus c. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other.